This is a short video to just go over the basics of how to do FNet practice. So remember that the overall equation that we're looking at is FNet, which is the sum, that's what the sigma, weird backwards E looks like, 3 looks like, sigma, the sum of all the individual forces. And this is the important part. They have to be acting in the direction of motion. So it's either all my forces in the x direction, or it's my forces in the y direction. But I'm never going to add forces in the x direction with the forces in my y direction. They're always completely separate. So that's an important point. So forces in the x direction are never added with forces in the y direction. Always separate. So then the question becomes, which forces am I going to be looking at, and which ones are the ones that are actually going to be equal to MA? So I have here an example. I have a box that's 50 kilograms. So just a reminder that the mass always goes inside the box. And there's lots of forces acting on it, 6 forces to be exact. I've color-coded it so that the x direction forces are in purple, and the y direction forces are in green. So the first question you have to ask yourself and answer is, what is the direction of motion? In our diagram, because forces are vectors and we represent them with arrows, the purple is the direction of motion because these are unbalanced, right? So if I add up the forces in this direction and the forces in this direction, they aren't equal to one another. The green forces are balanced. They cancel out. And you know that they cancel out because, one, the forces are pointing in the same axis, the y-axis. The FG is pointing in the opposite direction of FN, and they're the same length. So they're the same magnitude. They have opposite signs, so they cancel each other out. So this box isn't sinking into the ground, and it's certainly not rising up into the air. So I've got my direction of motion. I'm going to be adding up my purple forces. So I sum them up. So remember that anything that's moving to the right is positive. Anything that's moving to the left is going to be negative. So 80 plus 20 plus negative 30 plus negative 100 is going to equal MA, and MA is 50, don't know what the A is. So then these two are going to be equal to one another. So when I sum all of this up, that becomes negative 30 equals 50A, and that's going to be equal to negative 0.6. And at this point, I can now put in my units, and my units for acceleration are going to always be meters per second squared. So the takeaway, I've got to figure out which axis I'm going to be summing the forces, and it's going to be whatever's unbalanced. Once I figure that out, left is negative, right is positive, down is negative, up is positive. I sum them up, and then I make that equal to the mass times the acceleration. Now in this case, I know the mass, I'm looking for the acceleration. In other cases, I may know the acceleration and I'm looking for the mass. Or it could be that I know the mass and the acceleration, and I'm looking for the sum of the individual forces. So just like any equation, we can always have you figure out the missing variable, but it all comes in this case from the sum of all the individual forces acting in the direction of motion is equal to MA.